The light wave is an electric wave that passes through the outer space vacuum. Light waves are formed by vibrating electrical charges. For our purposes, it is simply sufficient to say that an electromagnetic wave is a transverse wave that has both an electrical and a magnetic component. As the electromagnetic wave moves towards you, you can observe that movements of the slink in more than one plane of vibration. This is very different from what you would find if you were to watch slinky wave traveling towards you. Indeed, the coils of the slinky would vibrate back and forth as the slinky approaches. But these movements would occur in a single plane of space. So in other words, the coils of the slinky can vibrate up and down or left and right. Regardless of their direction of vibration, they would travel in the same linear direction as you saw along the slink. If the slinky wave were an electric wave, the vibration of the slinky may have existed in several planes. In comparison to the normal slinky wave, electrical and magnetic vibrations of the electromagnetic wave exist on various planes. A light wave that vibrates in more than one plane is referred to as unpolarized light. The light emitted by the sun, the lamp in the school, or the candle flame is unpolarized light. These light waves are formed by electrical charges that vibrates in a variety of directions, producing an electromagnetic wave that vibrates also in a variety of directions. So this idea of unpolarized light is somehow difficult to imagine. But in general, it is useful to see unpolarized light as a wave with an average of half of its vibration in the horizontal plane and half of its vibration on the vertical plane. So unpolarized light can be converted into a polarized light. So polarized light waves are light waves in which vibrations occur on a single plane. So the method of converting unpolarized light into polarized light is known as polarization. And we have here four methods for polarizing light. We have the polarization by transmission, polarization by reflection, polarization by refraction, and polarization by scattering. So first, we have here the polarization by transmission, and Polaroid filter is used or is the most popular method of polarization by transmission because Polaroid filters are made of special materials capable of blocking one or two planes of electromagnetic wave vibration. In this sense, Polaroid functions as a mechanism that filters out half of the vibrations when the light is transmitted through the filter. As unpolarized light is transmitted via a Polaroid filter, it emerges one half of the strength and vibrations in a single plane. So it emerges as a polarized light. So as what we can see in the picture, the first one is the unpolarized light, which vibrations travels to different directions, and by using a Polaroid filter, one direction is blocked, so giving us the polarized light. The next one is by reflection. So unpolarized light may be also polarized by bouncing off non-metallic surfaces. The degree to which polarization occurs depends on the angle at which the light reaches the surface and the material from which the surface is produced. So metal surfaces absorbs light with a number of vibrational directions. Such reflected light is unpolarized, but however, non-metallic surfaces such as asphalt roadways, snowfields, and also water absorbs light in such a way that there is a high concentration of vibrations in the plane parallel to the reflecting surfaces. An individual observing objects by means of light reflecting off metallic surfaces will often see a glare when the degree of polarization is high. Like, for example, the fishermen, they know this glare because it prevents them from seeing the fish that lie under the water. Light reflected off the lake is partly polarized in a direction parallel to the surface of the water. But these fishermen know that the use of glare-reducing sunglasses with the right polarization axis allows this partially polarized light to be blocked. So by blocking the plain, polarized sun, the glare is maximized and the fishermen can more clearly see the fish underwater. So our example here shows the reflection of light off of non-metallic surfaces, which results in some degree of polarization parallel to the surface. Next one is by refraction. Refraction happens as the light beam travels from one substance to another. The course of the beam changes its direction at the surface of the two materials. The refracted beam has a certain degree of polarization. Polarization happens mostly or most frequently in a plane perpendicular to the surface because refractory light polarization can be illustrated by using a crystal that acts as a double refractor crystal. Iceland spar, a very unusual type of mineral, refracts incident light through two distinct pathways. When entering the crystal, the light is divided into two rays. Subsequently, if an object is viewed via an Iceland spar crystal, two images will be revealed. The two pictures are the products of a double light refraction. So both beams are polarized, one in a position parallel to the surface, and the other one is in the direction perpendicular to the surface. So since these two refractory rays are polarized with a perpendicular orientation, a polarizing filter can be used to fully block one of the images. If the polarization exists, or if the polarization axis of the filter is oriented perpendicular to the plane of polarized light, the light is completely blocked by the filter, while the second image is as bright as it can be. If the filter is then rotated 90 degrees in either direction, the second image will reappear and the first image will vanish. Now, that's a pretty neat phenomenon that could never be observed if there was no wave-like activity in the sun. And lastly is the polarization by scattering. It often happens as light is spread while passing through the medium. When the light reaches the atoms of the substance, the electrons of the atoms are also placed into vibration. The vibrating electrons, the vibrating electrons then generate their own electromagnetic wave, which is radiated outward in all directions. This newly produced wave hit nearby atoms, causing their electrons to vibrate and at the same original frequency. These vibrating electrons generate another electromagnetic wave that is once again vibrating or radiating outward in all directions. This absorption and re-emission of light allows the light to spread across the medium. The dispersed light is partly polarized. So polarization by scattering is observed as light travels through the atmosphere. The scattered light also creates a glare in the sky. Photographers, they recognize that this partial polarization is dispersed light contributes to image characterized by a bright sky. So the problem can be easily corrected by Polaroid filters. As the filter rotates, the partially polarized light is blocked and the glare is minimized. So the photographic trick of capturing the clear blue sky as the source of stunning foreground lies in the mechanics of polarization and Polaroid filtering.